Alright, lecture 5 here on your FANUC programming. We're going through chapter 7 in the manual. And very important chapter here. It's how you're going to get through a lot of the labs if I'm over helping someone else. These are going to be some of the most basic error and fault recoveries that you're going to need to go through, alright, as we go through this. So we should be able to recover from basic errors and faults here. Get out of Singularity, alright, also test question there. Experience software access limits, set those. Alright, we're going to go through in the lab, and I'm going to make you change the axis 1, the x-axis, to -10 and +10, and then try to move the robot and see what happens when you get to one of those axis limits. We want to recover from basic DCS faults and then chain failure detection error. Alright, lots of reasons hardware, software external, e-stops or things like that, over travels occurred. Lots of different errors can occur. It can be stuck in running another program, or basic things like that. You letting go of the dead man's kind of a fault error. So we need to be able to recover all these errors. The majority of our errors are going to be recovered by using the shift and reset. As we go through this, that will be your friend. You're going to get used to the dead man error, and you will always have to use shift reset. Okay, we can also always check the alarm log. Alright, so we can hit menu, go down to alarms, and we can take a look at the alarm log and see what's happened. It'll tell us, looking at the screen here, we can see if it's a servo 12. We had a servo 62 error not too long ago, so the batteries all died, so none of the axis, none of the servos would work. So we had to put new batteries in the FANUC and then remaster it. So just simple things like that, where you gotta, and then when you remaster, you gotta remember to clear all the certain right spots. There's always one that you kind of forget to clear out of all the alarms, but for the most part, you can check the alarms. It can hold up to 100, and you can delete all 100 alarms as you go through and reset and clear everything. Okay. The most common one, some of you guys have already experienced this, trying to move the robot around, is the DEADMAN Switch error. You got to make sure that you find the center position. Alright, it's designed that if you squeeze too hard, alright, because something happens to you in the cage with the robot will stop. And if you let go, the robot will stop, right? Something happens, you drop something, it hits you, the robot will stop immediately when you let go of it. Alright, so you got to make sure that to clear the error, you have to be in the center position on the dead man, and I'll show you with the teach pendant in hand, so it'll make more sense when we're actually in class. Alright, and teach pendant, dead man in the center position. Alright, shift, reset, and you'll see the fault clear right off your screen. Alright, we're going to get this a lot when you guys start running your programs, or you might have too fast kind of speed. But we're going to do this one on purpose in lab so that you can see how to get back in. But we're going to do a DCS error, a dual check safety issue error, and we're going to actually have you try to jog the robot out of the envelope. Alright, now when that happens, you're going to see that error on your screen, servo 402 DCR cart position limit. When you see that, that means you've moved the robot outside the working envelope. The only way for you to get the robot back inside is to make sure that you are in joint. Okay, first of all, so you have to hit coordinate and be in joint, and then you have to hit shift and reset, clear the error. Make sure when you do all this that your hand is in the center position on the teach pendant, and you have to jog in joint back into the working envelope. That's the only way that it'll let you do that. Now, you guys are going to be in the middle of running your program and have to change something, or you might get a DCS error or a fault in the middle of your program, and you need to fix like a speed or slow a speed down, because you'll get a DC error, speed error, and you'll fix your program and you'll try to run it again and it won't work. You'll hit the cycle start button and it won't work. Well, if you read the top of the screen, it says run request failed, already locked by other task. Very common error. You have to hit function and then abort all. Alright, then shift reset. Alright, clear your error, clear the fault, and then you should be able to work. So anytime that you're already locked by another task, it's function, alright, and then number 1, which is abort all. Common error as well, especially if we always start in mechanical 0. All right, you'll get a singularity definition. So that means that the robot doesn't know which way to go. All right, because it has two different ways of getting to the one point. All right, and this only occurs in Cartesian. So when you're in world, if you get a singularity error, what you do is you change J5, the wrist, plus or minus a certain amount of degrees, and you'll be able to toggle through and get right out of there. All right, so the test question is for that. In order to do this, all right, you're gonna hit the coordinate key. You got to move back into joint. All right, so get out of the world, get into the joint, and then you move J5 plus or minus 10 degrees. Test question right there, okay? So moving that forces it to know which way to turn when it's back in Cartesian coordinates. So that's why instead of leaving the robots in mechanical 0, we leave the robots in a perch type position, all right, with the J5 already at least 10 degrees up, so that when we start a program in auto, we don't have a singularity issue. All right. Motion groups. All right, we're not going to get into a lot of motion groups in class when we start programming. All right, we can have up to 9 axes on a single group, and we can have a maximum of 8 motion groups in the controller. Okay, so for all intents and purposes, a motion group, one controller can control up to a certain number of robots, right? So one controller can control 6 axis robots, because there's 36 axes there, right? And so just we can only control up to a maximum of 40 axes. Okay, so that's why it's important too when you call them with the FANUC number, right? That you have the controller number that's on the unit and the robot number, because they don't always match, because that controller can control more than one robot. So we set that when we set programs, and I'll show you when we do that. Okay, you can go above and beyond our 6-axis robot, so we can have 3 extended axes, like I said, up to 9 axes that belong to a single group. So different end of arm toolings and those sort of things that can change. But the first 6 axes of your robot must always be assigned to group 1. So there's other peripheral equipment that we can do for that. Okay, so when we take a look at this, okay, this is our hexadecimal code. So this is going to tell us which axis is going to be in error. You don't have to memorize this, because this is going to be in the manual, but you'll be able to look at this and kind of interpret it. Okay, so on your screen, if you get a motion limit error, okay, it's going to give you a number. It'll say, all right, G1A001 hex. All right, you have to interpret the 3rd digit, the 2nd digit, and the 1st digit. So if we're looking at this chart here, okay, the hexadecimal digit, if we have 001, okay, that's hexadecimal 1, okay, so, and it's hexadecimal 0. So 0 means none on the 3rd digit, 0 means none on the 2nd digit, and then 1 is the 1st digit. That means axis 1. So you got to go 001 and interpret that. Maybe it'll make sense in the next one here. If we look at G1A010, okay, if we interpret 010, we're going to get axis 5. So the 3rd digit is 0, so that means there's no axis issue. The 2nd digit is a 1, so looking at the chart, a 1 in the 2nd digit means axis 5. And then a 0 on the 1st digit tells me that there's no axis. So it's only axis 5 that's in fault there. If we look at the next one, where it gives us G1A:011, okay, 0 in the 3rd digit means there's none. And then it gives me a 1 in the 2nd digit, which tells me axis 5. And then it gives me a 1 for the 1st digit, which tells me axis 1. So now I have 2 axes that are in fault there. Alright, so hopefully this is starting to make sense. Let's go down to the bottom one. It says G1A052 hex. Alright, so 0 for the 3rd digit means what? None. 5 for the 2nd digit, you got to go down the chart a little bit, means axis is 5 and 7. Alright, and then a 2 Okay, for the third digit tells me axis 2. So axis 2, 5, and 7 are all at fault there. You'll know when you get a servo 62 error because all axes will be at fault there. But just a way to interpret the motion error and which axis you need to look at or correct when you get this issue and you mess something up in your program. All right, chain failure detection error. There is no chain on the robot or anything like that, so that verbiage just kind of throws you off a little bit. All right, but what the chain error really is the interlocks on like the gate or the cell or on our cart. Something happened where those weren't interlined, or you have a door open and it needs to be closed. All right, so if you get a chain fault error, that's really what it is. And there's nothing necessarily to do with the robot. It's a safety kind of issue where your sensor's gone out or your sensors aren't aligned properly. So when we move like one of the robots down to the gym for when we have like the incoming freshman orientation or something to show off the program, if it rattles too much as we're going down the sidewalk, the sensors become a little loose and don't become aligned, so we get a chain error. So we have to find out which sensor that is, make sure the door is closed or whatnot. We have to clear the alarms, so we have to hit hit menu, go to 4, go over to alarms. We're going to have to clear the alarms, so we're going to reset channel 1. We're also going to have to shift reset, and I always tend to cycle power, turn it on and off, but we reset channel 1 here on the screen. Alright, and then it says reset the channel fault. You say yes. Alright, then everything is good. Alright, next part, this is in your lab as well. You need to be able to go through and find the status version. You're going to hit menu, next, status version ID, and it's going to give you everything you need. You might need this for when you call the help desk. Alright, they're going to ask you what software you're running, so you're going to say handling tool. If we were using the big robot, we might say spot tool. Okay, so it just kind of just depends on the software. It's going to have what robot it applies to. So in this case, it's a 2000 IB 165F. Okay, and then the software edition, that's at the bottom, v1.70p/33. So all just different things that they might ask for. The controller ID would be like the F number, the robot F number, and I've shown you where that is on the robots and on the controllers. But this is something, the only time you'll ever really go through this is if you call up the help desk and they need to know everything that's kind of like tied on that robot. Alright, so what you're going to go through and do is you're going to view the axis limits and do the lab. The most important thing you need to do in this, before you change the axis limits, you need to take a picture with your phone, okay, of what the original axis limits are before you change them. And I only really want you to change axis 1 anyways, make it plus or minus 10, and then reset it back to normal. Other thing, when you change the axis limits, so you're going to go in, you're going to view the axis limits, you're going to do the lab, you're going to change it to minus 10, plus 10, you need to cycle power. If you don't turn the controller off and back on, it doesn't redo the axis limits and you don't get to see what's going on. So make sure that you cycle power after you set the axis limits. Alright, and then since you took a picture, you need to put the axis limits back to the original value they were, cycle power, turn on and off. Then you'll move into lab 6, and which is what I just talked about, looking at version number, F number, and that sort of thing. Alright, any questions, go ahead and email me or ask them in class. These 2 labs shouldn't take too long, but please call me over for lab 5. I want to see that you get the axis limits and you get the error and you're able to go back and forth. It's really cool because, I mean, technically you're creating a working envelope for yourself. Not only for safety, but equipment, that you don't damage and that sort of thing. But, alright, anyhow, I will see you guys in lab.